rates of change. Okay, what is rates of change in calculus? Okay, rates of change in calculus basically means the change that happen to a certain quantity in terms of time. Okay, for example, let's say I have a, a bucket. Okay, a bucket, and then drops of water, uh, is going in. Okay, drops of water, let's say from a tap. Okay, each drop of water after every 1 second, as the water drops keep going in, filling in the bucket. And after so many hours, okay, what is the amount of water that would have collected? Okay, or what is the shape of um, the surface area? Okay, what is the shape of the surface area of the bucket? Okay, if you look at it, bucket is in shape of a truncated cone. Okay, so from bottom to the top, okay, the shape is still circle, but the circle is just keeps expanding. So these are what happened to the shape, okay, which is in shape of circle, and how long it takes. So this is what rate of change that happens to a certain quantity in terms of time over a period. Now let's look at one example. Let's say air is being pumped into a spherical spherical balloon. Okay, very common example of question that you get. Okay, spherical balloon, such that its radius increases at a rate of 7 point 0.75 cm per minute. Find the rate of change of its volume when radius is 5 cm. Okay, air is being pumped into a spherical balloon such that its radius increases at a rate of 0.75 cm per minute. Find the rate of change of its volume when the radius is 5 cm. So as the air goes in, of course the volume is going to change. Okay, this is what we're going to find. Okay, so since it's volume, let's find out what's the formula for the volume of a sphere. V equals to 4 over 3 pi r cubed. Okay, that's the volume of a sphere. Now your next step is you differentiate V. Okay, first thing, if the formula is given, okay, write down the formula. If it's not given, then make sure you know what's the formula, or you can work out the formula for some questions. So let's differentiate this. dV over dr equals to basically the rate of change of volume, okay, the change that happened to volume in terms of time, divide by the change of radius in terms of time. Okay, so this is the formula. The formula varies. If it's area, dA over dr, or area, and if the length is given as x, then dA over dx equals to dA over dt divided by dx over dt. Okay, this formula is pretty much the same. Basically V and R is based on the question. Okay, we'll do a couple of examples and then you should be able to understand this. Okay, now once I've got this, let's look at all the information that we have. Okay, volume, dV, find the rate of change of its volume. So what they want is the rate of change over the rate of change of its volume. So rate of change means change that happens over time. So, and over here they're talking about volume. So out of these three formula, which one that they want us to find? Certainly is the V dV over dt, because it's the rate of change of its volume. Okay, over time, and r is given as 5. And what are the informations that we have? Okay, other information that I have is 0.75 centimeter per minute. Okay, spherical balloon such that its radius increases at a rate of 0.75 cm per minute. So that is the change that happen in radius over time. So that's given. So one information is given, dv over dr. I can find that. So let's do this separately. Okay, so dv over dr is 4 pi r square, and this time r is given as 5. So r is given as 5, not 3. Okay, 5 cm. And then dv over dt is what we required to find. Okay, the question requires to find. So this is dv, and then dr over dt, the rate of change for radius is 0.75. So from here, dv over dt equals to 0.75 multiplied by 4 times pi times by 5 square. 5 square. Okay, so the answer is 3 over 4 times 25 pi, which is 100 pi. 100 pi, and the answer is equal to 75 cubic centimeter per minute. Okay, I'm going to write it over here. Okay, 75, I'll write it over here. 75 cubic centimeter per minute. Okay.